Good day, everyone. Welcome to our General Mathematics class. I am Ma'am Captain Rose Yaga, Mathematics teacher at San Roque National High School. I am here to assist you in learning the lessons of the List Learn competencies in General Mathematics. Let us learn and enjoy. Our lesson for today is about solving exponential equations. What you need to know. At the end of the lesson, the learners will be able to solve exponential equations. Before we proceed with our lesson for today, let us first review the laws of exponents. Number 1. Multiplying powers with the same base. In multiplication of exponents, if the bases are the same, then we copy the base and add the exponents. X cubed multiplied by x squared. So since the bases are the same, which is x, all we have to do is to copy the base x, then we add the exponents. So 3 plus 2. So this will become x raised to 5. Let's have some examples. Letter A, 2 cubed multiplied by 2 squared. Copy the same base, which is 2. Then add the exponents. 3 plus 2 is 5. So this becomes 2 raised to 5. Letter B, 3 raised to 4 multiplied by 3 squared is equal to, copy the same base, which is 3. Then add the exponents. 4 plus 2 is 6. So this one becomes 3 raised to 6. Number 2. Dividing powers with the same base. In division, if the bases are the same, then we copy the base and subtract the exponents. A raised to m divided by a raised to n is equal to a raised to m minus n. Let's have some examples. Letter A, 2 raised to 7 divided by 2 raised to 4. Copy the same base, 2, then subtract the exponents. 7 minus 4 is equal to 3. Therefore, we have 2 raised to 3. Letter B, 5 raised to 7 divided by 5. Copy the same base, 5, then subtract the exponents. Remember, 5 has an exponent of 1. So 7 minus 1 is equal to 6. Therefore, the answer is 5 raised to 6. Number 3. Power of a power. In power of a power, we copy the base, then multiply the powers. The quantity a raised to m raised to n is equal to a raised to m times n. Let's have some examples. Letter A. The quantity 2 raised to 3 raised to 4 is equal to, copy the base 2, then multiply the powers. 3 times 4 is 12. Letter B. The quantity a raised to 2 raised to 3 is equal to, copy the base a, then multiply the powers. 2 times 3 is 6. Number 4. Negative exponents. If the exponent is negative, we need to change it into positive exponent by writing the same in the denominator and 1 in the numerator. If a is a non-zero integer or a non-zero rational number and m is a positive integer, then a raised to negative m is the reciprocal of a raised to m. A raised to negative m is equal to 1 over a raised to m. Let's have some examples. Letter A, 2 raised to negative 1. So this will become 1 over 2. Letter B, 10 raised to negative 3. This is equal to 1 over 10 raised to 3. Number 5, zero exponent. If the exponent is 0, then the result is 1. A raised to 0 is 1. Let's have some examples. Letter A, 4 raised to 0 is 1. Letter B, the quantity negative 2/3 raised to 0 is 1. Letter C, negative the quantity 2/3 raised to 0 is, so this is equal to 1. So this will become negative 1. What's new? Exponential equations are equations in which variables occur as exponents. Exponential equations are in the form b raised to x is equal to b raised to y. Which of the following are exponential equations? Number 1. 49 is equal to 7 raised to x minus 7. We have to take note the definition of exponential equations. These are equations in which variables occur as exponents. So let us identify if the following are exponential equations. In number 1, this one is an equation and it has variables in the exponents. So therefore, number 1 is an example of exponential equation. Number 2, 7 is equal to 2x plus 3. Number 2 is not an exponential equation. Why? Because there is no variable occur as exponents. Number 3, 3 raised to x is equal to 3 raised to 2x minus 4. Number 3 is an exponential equations. It is an equation with variables in the exponent. Number 4, is this an exponential equation? Yes. Why? Because it is an equation with variables in the exponent. Number 5. How about number 5? Is this an exponential equation? Not. Why? Because there is no variable in the exponent. Number 6. 4 raised to x plus 8 is greater than 64. Number 6 is not an exponential equation. Why? Because it is not an equation. It is an inequality. To solve exponential equations with the same base, use the property of equality of exponential functions. If the bases are not the same, rewrite the equation. If b is a positive number other than 1, then b raised to x is equal to b raised to y. If and only if x is equal to y. In other words, if the bases are the same, then the exponents must be equal. Let us solve the following equations. Number 1. 4 raised to 2x minus 1 is equal to 64. Take note that the bases are not the same. We have 4 and 64. But we can rewrite 64 as a base of 4. We know that 4 cubed is equal to 64. Now let us rewrite 64 as 4 cubed. So this will become 4 raised to 2x minus 1 is equal to 4 cubed. By the property of equality of exponential functions, if the bases are the same, then the exponents must be equal. Since the bases are already the same, we can equate the exponents. So we have 2x minus 1 is equal to 3. To solve for x, let us add positive 1 to both sides of the equation. Cancel. This becomes 2x is equal to 4. Let us multiply both sides of the equation by 1/2. Why 1/2? Take note that the product of a number and its reciprocal is 1. So our target here is to eliminate the number beside x. So we have to multiply this by the reciprocal of 2, which is 1/2. So 1/2 times 2x is x. A number multiplied by its reciprocal is 1. So this one becomes x, or 1x is equal to 1/2 multiplied by 4 is 2. So x is equal to 2. Number 2. 26 raised to 9x plus 5 is equal to 1. Take note, again, the bases are not the same. We have 26 and 1. But we can rewrite 1 as base of 26. We know that 26 raised to 0 is equal to 1. We write 1 as 26 raised to 0 so that each side has the same base. So this will become 26 raised to 9x plus 5 is equal to 26 raised to 0. As you can see, the bases are already the same. By the property of equality of exponential functions, if the bases are the same, then the exponents must be equal. So we will equate 9x plus 5 with 0. 9x plus 5 is equal to 0. Next, let us solve for x. Let us add negative 5 to its sides of the equation. Cancel. So we have 9x is equal to negative 5. Next, let us multiply 1/9 to both sides of the equation to find the value of x. So this will become x is equal to negative 5/9. Number 3, we have 2 raised to 3x plus 5 is equal to 64 raised to x minus 7. Note that the bases are not the same. We have 2 and 64. But we can rewrite 64 as base 2. We know that 2 raised to 6 is equal to 64. Now let us rewrite 64 as 2 raised to 6 so that each side will have the same base. So we have 2 raised to 3x plus 5 is equal to the quantity 2 raised to 6 raised to x minus 7. By the property of equality of exponential functions, if the bases are the same, then the exponents must be equal. As you can see, the base are already the same, so we can equate the exponents. We have 3x plus 5 is equal to 6 multiplied by x minus 7. Let us now use distributive property. So we have 3x plus 5 is equal to 6 times x is 6x. 6 times negative 7 is negative 42. Next, let us solve for x. Let us add negative 3x. So we cancel this part. Then let us also add positive 42 to both sides of the equation. So we have 47 is equal to 3x. To solve for x, let us multiply both sides of the equation by 1/3 to eliminate the number beside x, which is 3. So we have 47 over 3 is equal to x, or x is equal to 47 over 3. Number 4. 32 raised to x over 3 is equal to 8 raised to x minus 12. Again, the bases are not the same. We have 32 and 8. But we can rewrite 32 and 8 as base of 2. We know that 2 raised to 5 is 32 and 2 raised to 3 is 8. Next, let us rewrite 32 as 2 raised to 5 and 8 as 2 cubed. So this one will become the quantity 2 raised to 5 raised to x over 3 is equal to the quantity 2 cubed raised to x minus 12. By the property of equality of exponential functions, if the bases are the same, then the exponents must be equal. So we will equate the exponents. So we have 5 multiplied by x over 3 is equal to 3 multiplied by x minus 12. Let us apply distributive property. So 5 times x over 3 is 5x over 3 is equal to 3 times x is 3x. 3 times negative 12 is negative 36. Next, let us solve for x. Let us multiply both sides of the equation by 3 to eliminate the fractional part. So 3 multiplied by 5x over 3, this one is 5x, is equal to, let us use distributive property again. So 3 times 3x is 9x. 3 times negative 36 is negative 108. Let us add negative 5x to both sides of the equation. Cancel. Next, let us add positive 108. Cancel. So we have positive 108 is equal to 4x. To solve for x, let us multiply both sides of the equation by 1/4. So 1/4 multiplied by 108 is 27. Is equal to 1/4 multiplied by 4 is x. So the answer is x is equal to 27. Number 5. 5 raised to 4x plus 3 over 25 raised to 9 minus x is equal to 5 raised to 2x plus 5. The bases are not the same. We have 5 and 25. But we can rewrite 25 as a base of 5. We know that 5 squared is equal to 25. Let us now rewrite 25 as 5 squared. The equation now will become 5 raised to 4x plus 3 over, rewrite 25 as 5 squared so that the bases will become equal or the same. So we have the quantity 5 squared raised to 9 minus x is equal to, let us copy the right side of the equation, 5 raised to 2x plus 5. Let us now apply dividing powers with the same base on the left side of the equation, where a raised to x over a raised to y is equal to a raised to x minus y. So let us copy the same base, and subtract the exponents. So we will copy the same base, which is 5. Then we subtract the exponents of the numerator and its denominator. So we have 4x plus 3 minus 2 multiplied by 9 minus x is equal to, copy the right side of the equation, 5 raised to 2x plus 5. By the property of equality of exponential functions, if the bases are the same, then the exponents must be equal. Let us now equate the exponents. 4x plus 3. So we will apply distributive property here. So this will become negative 18 plus 2x is equal to 2x plus 5. Let us now combine like terms. We can combine 4x with 2x, which will become 6x. We can also combine positive 3 and negative 18. Positive 3 minus 18 is negative 15. Is equal to, copy the right side of the equation, 2x plus 5. Next, let us add negative 2x to both sides of the equation. Cancel. Then let us add positive 15. Cancel. This will become 6x minus 2x is 4x is equal to 20. Next, multiply both sides of the equation by the reciprocal of 4, which is 1/4. So 1/4 times 4 is 1. So this becomes x is equal to 1/4 multiplied by 20 is 5. So x is equal to 5. What you need to remember. Exponential equations are equations in which variables occur as exponents. If b is a positive number other than 1, then b raised to x is equal to b raised to y if and only if x is equal to y. In other words, if the bases are the same, then the exponents must be equal. Thank you everyone for watching this video. Truly, learning mathematics is fun. See you in our next video. Have a good day!